Hello, my name is Gary Parker, and I am currently at Blue Mountain Community College in Pendleton, Oregon. However, today, April 24th, I was supposed to be at Lincoln City at the Oregon Mathematics Association two-year colleges conference, but we're isolated, right? So we're not there. So all my friends at ORMATYC, I miss y'all, and I was going to give a talk about scalable vector graphics, so I'm going to do that for you now because I need something else to do besides grade papers. And I need some interaction, even if it's virtual. So here we go, SVG. I started a website here for the talk, and I have at the top a link to the slideshow. I'm going to get started with, I'm going to do this in parts, so about 10 to 15 minutes at a time, and post them starting today and for the next few days into next week. Mozilla Developer has a lot of great resources if you want to learn more. Most of what I know about SVG, all of what I learned about SVG, I learned online, and I read a lot of tutorials, watched a few videos. So here is my introduction to you about one of my favorite hobbies. So I'm a math teacher by trade, but I'm a computer enthusiast. I love playing with all kinds of computer stuff, especially the web. And the web is made up of structure through HTML. It's made up of sending stuff back and forth to computers, HTTP, and that the pages are styled with what's called CSS, and they're made dynamic, often with a programming language called JavaScript. And I like playing with all those things. SVG, Scalable Vector Graphic Format, is like HTML. It's a markup language, but it's designed for graphics. It's been around for a long time. One of the best things about it in the last, I don't know, 5-10 years of its development is browsers recently started rendering SVG in the browser. So that means SVG images can be in there. It used to be just like JPEGs and GIFs. Then we got PNGs. Now we get SVGs in there. So here's just a little example. This is an SVG image right here. It's living in an HTML page. And that green circle is defined by saying, hey, I want a circle. Here's its center, X, center Y, give it this radius, fill it with green and stroke, don't draw a line around it. Mozilla Developer, I link here to its introductory tutorial for SVG. They've got a lot of other web stuff that's pretty cool. Here, they depend on some HTML concepts. So if you know the HTML, that will help. I use another program called Inkscape, which is kind of draw, an online draw, not online, but what you see is what you get drawing tool, and I'll demonstrate that in another video coming soon. And so if you want to learn more, much of what I'm going to do came from here. You can see I borrowed their graphic here. Firefox, Mozilla runs Firefox, and they have a license that allows people to reuse their stuff, which is kind of cool. So this is the code right here for this particular graphic. An SVG tag that starts off the thing minimally needs a width and a height, and the namespace here attribute is optional. You should use a viewbox attribute, and I'll talk about that later too. Let's move along. Photographs versus graphics. So there's all different kinds of file formats for graphical images, kind of line drawing type things. And there's a bunch of for photographs out there. So this is a JPEG here, and this is an SVG. If we look at that image and then we zoom in on it, since most images like JPEGs and PNGs are basically a bunch of pixels, a bunch of squares on the screen or on a piece of paper, when you zoom in really far, you see the delineation between the different points, and this is what we call pixelation of an image. SVG does not have that problem, so if we get away from one of the great there and take a look at this cat zoomed in on, as you zoom in and out on an SVG, the browser redraws that curve based on the new position of those points on the screen. And you don't get pixelation until you reach, say, the limits of the pixels on your browser. But if this were a PNG image, we would get a very blocky edge on that. And so SVG is pretty powerful in that regard. Some examples here. SVG can make some very dynamic, complicated images. It can be used in infographics. A lot of online graphing calculators use SVG to draw the curves so that when we zoom in and out, they scale nicely and don't pixelate on us. I use SVG in my work. I use MyOpenMath for a homework system. And when I write problems for students, often I like a graphical illustration to go with them. And so I'll design an SVG graphic, and then I can redraw the graphic with different numbers. Like here I have a square drawn in thirds, and in halves, I could instead do quarters and fifths. So quick view of some of the stuff I do in MyOpenMath here. I teach math for elementary school teachers, and I try to help them figure out, like, why do we have to add fractions the way we do? Why do we have to have a common denominator? And that stems from what is a fraction and what does addition mean? And a fraction is an equal part of a whole, and addition means to combine and count. And we can only count things if they're like, if they have a like description. So this particular example shows the thirds and halves, but I've got a little randomization in here. So when the student regenerates a new problem, they're going to get a slightly different version of the problem. So this time they got 2/3 and 3/5. So these SVG are programmable because they have those attributes that I can go tell the browser to redraw with a different number, which is, I think, a great deal of fun. Oh, this is another example I wanted to show you. Let's bring that back. Google, if you use Google and a lot of other online tools like that, here we go. If you use Google Sheets, when you draw a graph, maybe a pie chart or a histogram or a bar chart, whatever, Google draws them with SVG images. And again, those SVGs are programmable, so we can have things happen, like when we point at something, it highlights and it tells us more about it. So here, in MyOpenMath, I wrote a little code to mix up the percentages each time, and then I go ask Google to redraw the graph for me. So if we generate a new one, then we'll get slightly different percentages coming around here, which is pretty awesome. So lots of services that you can use SVG with. Here and throughout the talk, I'll have places where you can not just go to get more information, but try stuff. So here I want to talk about the SVG coordinate system, the viewport, and the viewbox. So the viewport is the kind of the window we're looking through, and the view box is a little piece of that viewport. And it takes a little getting used to that, but it's a powerful idea in scaling and showing parts of an image. The coordinate system works the way browsers render things the way we read. We start at the top left, we read left to right and top to bottom. So when we design SVGs, the usual coordinate system is positive x-axis goes to the right, positive y-axis goes down. That takes a little getting used to. Some of the apps that you draw through and they write the code for you, they kind of flip the coordinate system for you for people that are used to y going up. So if you see a code pen exercise, that's a place where you get to play with me. So let's take a look. When you first open it, it's actually going to have this view here. And I prefer to change the view. I like the code on the left and the rendering of that code on the right. And all I'm doing is using HTML here. I'm not using CSS or JS. So HTML stands for Hypertext Markup Language. It is an XML, an extensible markup language like SVG is. CSS is cascading style sheets, and that kind of gives things a little more excitement on the screen. So HTML is structure, CSS is style. And then JavaScript is a programming language that allows you to make the page a little more dynamic to maybe interact with the user. But I don't have any of the CSS or JS here. So I'm going to maximize the HTML editor. So this is just showing HTML. I have a heading at the top, and then I say, hey, here's exercise 1, and then I have a paragraph that tells you a little bit about what I expect here. So in this case, you can place a point on the grid, copy and paste the circle in the SVG section in the HTML panel over here, change the center X, the center Y, the R, and the fill attributes. The circle is near the end. So I had a whole bunch of code I had to put at the beginning to generate the grid and the numbers going around here. And so that's what's at the beginning of this SVG. And this SVG, I have a few more things in it than the last one. I've got a width element here. I've got a height element here, or attribute, excuse me. SVG is the element. The things inside of it are the attributes. View box is an important one. The view box says where do we start in the coordinate system. So this one is starting at -70 for x, which is over here, and -70-ish for y, which would be up here. So this point over here would be the point -70.5, -70.5. And then it says make the width 391. So the distance from this edge to this edge is 391 pixels on the screen. And pixels are kind of a malleable thing, because when I zoom in and out on the screen, the pixel size kind of changes. And SVG adapts to that nicely. So I mentioned earlier there's a viewport and there's a view box. So this view box lives in my viewport. I currently have a zoomed in on viewport. Now I'm zooming out on that viewport. So the pixels are relative to the size of the viewport. Back in. And again, if you want to read more about how the viewport, view box things works, and then there's a whole user coordinate system, which is another thing. If you want to program this stuff, you do need to understand the difference between the viewport, the view box, and the user coordinate system. But if you're just drawing them, it's no big whoop. The important things is it's usually a good idea to give a width and a height. The view box is a good idea to have. If the view box isn't present, then the interpretation would be start at 0, 0 and use whatever the width here and the height is for the width and height here. These width and height for the SVG do not have to match the width and height of the view box, but then weird stuff can happen if you don't know what you're doing on those. Whole nother issue. Let's not worry about it. Let's scroll down and do something. So eventually we see, there it is, the circle on line 38. And a point, really, there's no point element. Instead, we just make a little circle. So I'm just going to copy this circle here, Control C, get a new line or two, Control V, and I'm going to redraw it. So let's say I want to put it over here at x equals 200, y equals 50. So I just go and change the center x value to 200 pixels and the center y value to 50. And then it's still got that big old radius, so I'm going to knock that down a bit. Let's try a radius of 5 and see what that looks like. Okay, kind of big. Let's go 4. All right, and then as you type stuff here, what are we using here? CodePen eventually looks to see you made a change and redraws it over here on the side pane. I have the fill set to orange. Let's pick a different one. Let's make it, how about blue? And so I should get a blue point. And by default, it looks like it does not have a stroke. So let's add a stroke for fun. Each element has attributes, and every type of element has slightly different attributes, but all of the basic shape things have a fill and a stroke. And when you set an attribute, you always give the attribute name equals quotes for the value. So it's always name of the attribute equals attribute value. And stroke is expecting a color. There are about 140-ish named colors that browsers know. Otherwise, to get access to the other almost 17 million colors that computers know about, you have to use something like a hexadecimal code. So that's a whole nother story too. Let's try a stroke of red. Nice easy color. And so then it should draw a little red ring around it. I can also say, let's make the stroke width different. So there is an attribute called stroke width. And there's a ton of different attributes, and I'm always learning about new ones. Let's make it 2 pixels. The default is 1. And it draws the width from the center of the radius. So that means the middle, imagine a middle line in that red circle there. Zoom in a little. Draw a center circle within the red ring here. That would be 4 units out. And then the stroke of 2 would mean 1 unit goes within the circle and 1 unit goes outside, which is the way most, I think, browsers and image drawers render SVG strokes. That's it for now. I just wanted to give you a brief introduction. How could you use this in the classroom? Well, there's lots of uses if you put your imagination to it, but here really I'm just playing with something I have fun with. When we first got into isolation, I was kind of in this weird ambiguous state, like, what do I do with myself? Little did I know how much my workload would increase with all my courses online. But in the brief lull I had around spring break, I decided, can I draw my own version of COVID-19 in SVG? And here I was trying to draw it with as little code as possible. And this is like the evolution of my drawings here, heading through top left to right, top to bottom. And I would draw like one little piece, and then I would tell the SVG to replicate itself coming around. And I'll post a link to this later. And then after I started liking what I was drawing, I said, ooh, can I animate them? So you can see these little pieces are breathing here, and the sucker down here is rotating. So this was a one-day spring break project before work really hit hard. And maybe I'll get back to it someday soon. Hey, thanks for playing with me. I hope to see you in the near future, either virtually or for real. I'm Gary Parker. Bye-bye.